Computer Programming Essentials, Unit 4, Part 2. In the last unit, you may recall that we were talking about writing methods and creating methods. And every method that we are going to write in this class starts with the access specifier's public static. Public means that it's accessible to all clients of this class. We don't really need to know what that means right now, but I thought you might be interested. And static means that it exists when no objects of the class exist. Static means that it exists when no objects of the class exist. Everything that we create, all the methods that we create, are going to be static because we are not getting into object-oriented programming in this class per se. We will not be creating objects of classes. So we will always have public static in our method headers. What follows next is void. That's the return type from the method. And then the name of the method or method identifier followed by parentheses. Method names are always followed by parentheses. Whether you are declaring the method or calling the method, it will always have a set of parentheses after it. So, in order to return something, the methods headers we've seen so far have always had void. They have not returned anything. But in order to return something, we must specify the data type of what's being returned by the method, as well as use the return statement. So if no data is being returned by the method, we use the keyword void, and that's all that we've seen so far. But if we are returning something, we have to put the data type of what's being returned. Here's an example where we have the word void, which is the return type. Both main and name and address have void as the return type because they do not return anything. Method names, again, can be any legal identifier. It must be one word, no spaces, and no special characters, cannot be a Java keyword. And by convention, we start method names with a lowercase letter. The only identifier that starts with an uppercase letter in Java would be a class name. Java, again, doesn't care. Java doesn't care whether you use uppercase or lowercase. But it's some rules of style that all programmers agree on. Yes, we will name classes starting with an uppercase letter just to give us a clue as a programmer that it's a class name. So all method names, all variable names, they all start with lowercase letters. And here's another example. Every method header contains a set of parentheses that follow the identifier or the method name. And the parentheses can be empty if we're not sending anything to the method for it to do its job, but if we are, they would have a parameter list. A fully qualified identifier is a method name that includes the class name. Can you recall an example that we've seen of that so far in this class? If you said jOptionPane.showMessageDialog or jOptionPane.showInputDialog, congratulations, that's a right answer. There are other right answers as well. Sometimes students surprise me and come up with things that I wouldn't have thought of, but that's one example. Here we're showing the example with main, how it does have a parameter list. It's got string args, and it's actually not used, and I'm not going to talk about exactly what it is because it's an array and that's beyond our scope right now, but that has a parameter list. Name and address does not have a parameter list, does not need any additional information. Now, arguments and parameters, these basically are referring to the same thing, but there is a subtle distinction. The way that I remember this is because it's alphabetical. Arguments come before parameters. If you are passing data to a method for the method to do its job, it's called an argument. If you are receiving information in that method, it's called a parameter. So what you send is an argument, and what you receive is a parameter. When we put all of the code inside a method, when someone's using that method, they don't have to know exactly how it works. We call this implementation hiding. They just have to know that it works. To call a method, all you need to know is what it's returning, what the name of the method is, and what the parameter list looks like. You don't need to know exactly how it's doing its job. An example of that is jOptionPane.showMessageDialog. Do we know exactly the lines of code that go into producing that output? We don't. All we need to know is that it will produce the output. So that's an example of implementation hiding. The interface, that's the jOptionPane.showMessageDialog, and the fact that null is the first argument and then there's a second argument. That's all we need to know to be able to use that method. That's called the interface, and that's the only part that the client needs to see. When we're writing our programs, we are a client of jOptionPane.showMessageDialog or jOptionPane.showInputDialog. So if we want to create a method that receives a single parameter, we start with the optional access specifiers. It's going to be public static, and then the return type for the method, then the method name, and then the parameter type. In parentheses, we put the parameter type, whether it's int or double or string or char or boolean, and then a local name for the parameter. What are we going to call that parameter inside the method? Here's an example. If we want to write a method called predictRaise that doesn't return anything but accepts a single double parameter, we would put the word double, that's the data type, followed by whatever we're going to call that piece of information for the duration of this method, in this case, salary. Inside this method predictRaise, we declare a new variable called newSalary. It is a double. We create a final, which is final double raise rate equals 1.10. Notice that raise rate is all caps, and we do use the underscore. I have said no special characters, but some are allowed, such as the underscore, and in this case it's an appropriate use. New salary equals salary times raise rate, so we're taking whatever the parameter is, whatever's in salary, we're multiplying that by the raise rate, and we're storing the result in new salary. And then we have an output statement, system.println, current salary, that's our string literal that will be displayed, plus whatever's in the variable called salary, plus after raise will be displayed, plus whatever's in the variable new salary. You can, if you want to, take a moment to try to type this up into a new Java application and see if you can figure out the lines of code that will call this method. If not, you can always look them up in the book if you can't figure it out. This method will need to be called with a double parameter. You need to pass it some value that can be supplied to salary. A local variable, we looked at new salary, it was declared within the boundaries of the method, and that is known as a local variable. So let's go back just for a second. See where it says double new salary? It declares that variable, and that variable exists from the moment it's created at double new salary until the end, the closing close brace, the ending close brace of the code block in which that variable is declared. So when we hit the end of the method predictRaise, new salary goes away. Its lifetime is over. So it's a local variable to predictRaise. When predictRaise is over, so is that variable. Here's another example of how we can call predictRaise. Notice that up in public class demo raise, public static void main string args, double salary equals 200.00. Double starting wage equals 800.00. Then we have a system.println demonstrating some raises. And then we call predictRaise and we're passing it the value 400.00. That value 400.00 is a numeric constant and it will be passed to the variable salary. Salary will be created, it will store the variable, the value 400. It will then predictRaise will go on to declare a double new salary, to declare a final double raise rate equals 1.10. New salary equals salary times raise rate, system.println, current salary is 400, after raise it's 440, and then it will end. Salary will go away, and new salary will go away because both of those values were created for predictRaise. Control will transfer back up to where predictRaise was called, and then it has another call to predictRaise, and what it's passing is salary. What value is in salary at that point? The value 200. Notice that in our call, predictRaise salary, we are using the same name as we use in our parameter list where it says public static void predictRaise double salary. It's the same name. Doesn't have to be. The only thing that has to match is the number. We're passing one parameter. We're passing one argument, receiving one parameter, and the data type. Both are type double. So the data type has to match and the number of arguments has to match the number of parameters.